Hi everyone, my name is Alice, and today I'm going to be talking about a topic in chemistry, in other words, atoms. Alright, so the first thing that you need to know about atoms is something called the atomic theory of matter. So this is a really basic concept in chemistry, and basically it says that atoms make up all matter. Atoms make up all matter, and each atom is a different kind. So all of these different kinds are called elements. And the number of elements is limited. And you probably already know, but elements are classified by the number of protons that they have in the nucleus. But basically what you need to know is that atoms are all different kinds of elements. You have oxygen, lead, boron, neon, all of those different elements. And you need to know that atoms combine to form molecules. So these different vocabulary words, atoms, elements, molecules, they're important, but they're also very basic, so you should already know those. All right, so elaborating a little bit more on atoms, what are they? So atoms, the word, comes from atomos, which is Greek for indivisible. So even though an atom is made up of different parts, it's actually the smallest indivisible sort of entity. So it's made of protons, electrons, and neutrons, but those alone cannot exist out in the world. So they have to be together in the atom, the atomic unit, in order to exist in the world. So like I mentioned before, they're made of protons, electrons, and neutrons. And so when atoms were first discovered, the biggest question was, how exactly are these parts arranged? There are so many different kinds of things, and how exactly do they fit together? It was sort of the puzzle that they had to figure out. So one of the earliest theories was from a guy named J.J. Thomson. And in 1897, he basically discovered that the atom is a neutral charge. So overall, there is a neutral charge. And he discovered that you have both electrons, so you also have to have protons. And so he put together something called the Plum Pudding Model. And nobody really eats plum pudding today, but the idea is sort of like this. So in this model, I sort of have everything laid out very proportionally, and it looks like everything is very, very neat. But you can sort of think of a chocolate chip cookie where you have a lot of the different ingredients, in this case the electron and the proton, and they are all in there, but they're sort of scattered in different areas. But if you look at the cookie or the atom as a whole, there's no specific part where you're going to find all the electrons or all the protons or all the neutrons. So the very, very first model was this, the Plum Pudding Model. So this is sort of also the most intuitive. And eventually, actually, Thomson's student came along, and his name is Rutherford. So you might recognize him, but in 1909, he put together something called the Planetary Model. And as you know, in the solar system, in the middle you have the sun, and then you have all the planets that orbit the sun. And so he sort of used this model to describe what the atom looked like. So what he did, he suspected that the charges in the atom, the positive and the negative charges, weren't exactly put together just kind of randomly like in the cookie example. He actually thought that the organization was a little bit different. So he put together this experiment, which, and I have alpha particles in parentheses because basically he shot a bunch of alpha particles at atoms and tried to see if he could sort of get an idea of what the atoms looked like through that. And so what he put together was sort of this kind of model where you have the yellow in the center, which is mostly the positive charge, in other words, the nucleus. And then all the black dots in all the different areas, and the black dots kind of represent the electrons. So he thought that it was just sort of a cloud model where the electrons weren't really orbiting in a specific route or a specific way. They were just sort of everywhere outside of the nucleus. So basically, he shot these alpha particles, and what happened is that, sort of like this, so instead of getting all regular results, which you would expect that all the particles would just go straight through because it would be like running through a cloud, for example. Like there's nothing to stop you, even though there are technically things in the cloud, nothing's going to stop you. And so with the nucleus in the middle, however, you do have sort of a reflection going on. So you can see that right around here, around the yellow nucleus, you have a deflection of the alpha particles that are shot in that area. And so because of that, Rutherford sort of could infer that you have something in the middle that is charged, and then everything else sort of surrounds it. So that's why he came up with the planetary model. And so, as we know, this model is not perfect. There are some flaws because the actual atom is not exactly like that. And so the next iteration of what the atom looked like actually came from Bohr. So Bohr is also a very big name in chemistry, but what he came up with was almost correct. So he sort of learned from Planck and Einstein, yes, Albert Einstein, that light energy exists in quanta. And that's not really a word that we use very often, but basically it means that it sort of exists in different stages. And the way that I like to think about it is like a staircase. So instead of being able to be like on step 2.5, there is no such thing as being like in between steps, right? So when you're on a staircase, you're either on the bottom step or the first step or the second step. There are only whole numbers. There's not sort of a gray area. So there's completely no gray area when you're talking about stairs or when you're talking about quanta of light energy. So it's from this knowledge that Bohr is able to come up with his atomic model. So this is a representation of it. So here in the middle you have the nucleus, the yellow nucleus. And then around it you have several rings. So here, since I have limited space on the slide, I only drew 2, but we know of many, many, many more, right? But basically, the black dots are the electrons, and you can see that the electrons orbit only on these specific rings or these specific quanta for light energy. And the reason that this model is not exactly correct is the idea of atomic orbitals. So I took this slide from this website in the corner, but basically different kinds of orbitals have different shapes. They're not just rounded circles, right? So they actually look different, and the electrons that are in those orbitals will only be in these kinds of shapes. So I will explain them more in depth in another video that I will link in the bottom when I have it. But you can see that they sort of get more complicated as you go on. And instead of just the circles, you actually have these atomic orbitals. So in the center you have the nucleus, and then you have these orbitals that are exponentially larger than the nucleus itself. So that's it. That's all I have on atoms and the origin of the atomic model and how we sort of understand how models or how atoms look today. If you have any questions, please feel free to drop your question in the comments below. If you like this video, I really hope that you will share it, like it, put some compliments down in the comment box. I always love those. And I will put this slide, this PowerPoint, and all of my other slides and other bonus material at that link It will be in the description below as well, so just go to that link and you will be able to access all of the slides and other bonus material that I've ever created. So thank you so much. I hope some of the videos over there can help you out, but other than that, have a great day. I will see you next time.